Hello children, welcome to maths class of standard 8. Now let us continue with our chapter perimeter in area. Now I have exactly one pair of opposite sides parallel. Who am I? Yes, you guessed it right children. It is trapezium. We have already seen about trapezium in our last chapter, understanding shapes. So a quadrilateral with exactly one pair of parallel sides is called as trapezium. So in this trapezium, you can see that PQ is parallel to RS. Now, if the non-parallel sides are equal, then such trapezium is called as isosceles trapezium. So in this quadrilateral over here, you can see that AB is equal to CD and BC is parallel to AD. So the trapezium should have, isosceles trapezium should have equal non-parallel sides and one pair of parallel sides. Now we have already seen a video to understand that area of a trapezium is equal to half into sum of parallel sides into perpendicular distance between the parallel sides. So if A and B are the parallel sides, then area of trapezium can be easily found by half A plus B into H, where H is the distance between the two parallel sides. So let us solve some problems based on this formula. Here is our exercise. The first question, find the area of the trapezoid. Now in here you can see that there are two parallel sides whose lengths are given to us. AB is 6 cm, CD is 16 cm. The distance between them, that is height, AE is 6 cm. So very easy, just substitute the formula. Area of trapezoid is half AE into AB plus CD. AB is 6, CD is 16, AE is 6. 2 ones are 2, 2 threes are 6. So 3 multiplied by 22 and answer is 66. Very simple question. Yet another problem over here where 14 and 9 are the length of the sides, parallel sides, and height is 20. So simple substitution and calculation will give us the answer 123 square centimeter. We have a problem over here. A trapezoid has a height 10 centimeter, one base of length 5 centimeter and area 60 centimeter square. So we are given area of trapezoid, we are given one of the parallel sides, and we are also told height. We have to find the other side. So use the formula of area of trapezium and substitute. Half height into base 1 plus base 2 equal to 60. So here we see that we can do the cancellations. 2 ones are 2, 2 fives are 10. Or you can directly use transposition, that 5 plus base 2 is equal to 60 multiplied by 2. Since 2 is in the denominator, it will go in the numerator, 60 multiplied by 2. And 10 is in the numerator, that it is multiplied, so it will be divided. So it will divide 62 into 2. Correct? So by transformation, 10 ones are 10, 6 are 60. So we get 12 over here. So BT is equal to 12 minus 5, which is 6 centimeter. So we got that the length of the other parallel side is 6 centimeter. Now that we have done some easy direct problems, let us look at this problem. Here ABCD is a trapezium in which AB is parallel to CD. So we have here AB is parallel to CD. AD is perpendicular to DC. So AD is 90 degree with DC. AB is equal to 20 centimeter, BC is equal to 13 centimeter. So here the non-parallel side is 13 centimeter and DC is 25 centimeter. That is this one. Find the area of the trapezium. Now we know the formula that area of the trapezium is half into height into base 1 plus base 2. Here base 1 and base 2 lengths are given, but we don't know height. So we will have to find the height first. Now if you can see BP is perpendicular to DC, correct? So it is a right angle triangle. So we can use Pythagoras theorem to easily find BP. But to use Pythagoras theorem, we need to know BC. Now if we draw this height BP, rectangle ABPD is formed. Since it's a rectangle, we see that this is 20 centimeter, then DP is also 20 centimeter. So PC can easily be found out by DC minus DP. Correct? 25 minus 20, which is equal to 5. Since opposite sides of rectangle are equal. So we will first know DP, it is 20. 25 minus 20, we will get that PC is 5. So using Pythagoras theorem, we can easily find PP. Correct? So let us start. In trapezium ABCD, AB is parallel to CD, AD perpendicular to DC, AB and BC lengths are given, DC length is also given. So since BP is perpendicular to DC over here, ABPD is a rectangle and opposite sides of rectangles are equal. So CP will be is equal to, that is this part, CP will be is equal to CD minus DP, which is 20 centimeter. Correct? So we got our PC as 5 centimeter. Now, since altitude is perpendicular to the base, triangle BPC is a right angle triangle. Hence, by Pythagoras theorem, which is the hypotenuse, BC is the hypotenuse. So, by Pythagoras theorem, BC square will be equal to BP square plus PC square. Substitute. So, BP square is equal to 169 minus 25. That is 13 square minus 5 square. And answer is 144. So we can say that BP is square root of 144, which is 12 centimeter. Once we get BP, we know the formula of area of trapezoid. Substitute and get the answer. So 2 ones are 2, 2 6 are 12, 6 multiplied by 45, which is 270 square centimeter. So children, if height is not given, remember that we can easily find it by Pythagoras theorem, since height is perpendicular to the base. Now let us take this example. If the height and area of trapezium are 11 decimeter and 396 decimeter square and the parallel sides are in the ratio 3:5, then we have to find the lengths of the parallel sides. So here we have a trapezium and the ratio is 3:5. That means the length of the sides can be taken as 3x and 5x respectively, where x is the constant of proportionality. And the height is given 11 decimeters and the area is 396 decimeters. So since the ratio is 3:5, we will take the length of the sides as 3x and 5x, where x is a constant of proportionality. So let us start with this problem. We have the parallel sides ratio, that is ratio of parallel sides 3:5. Height is 11 decimeter and area is 396 decimeter square. So let the parallel sides be 3x and 5x, where x is a constant of proportionality. Area of trapezium is given by 396 square decimeter. So half into height into sum of parallel sides. So height is given as 11 decimeters and 3x plus 5x would be sum of parallel sides. So 3x plus 5x is 8x. So 11 multiplied by 8 will be equal to 396. 11 multiplied by 8 upon 2 will be equal to 396. Therefore, x will be equal to 396 upon 44. Correct? Here 2 ones are 2 and 2 fours are 8. So 44. So this 44 will come in the denominator by transposition. So which is equal to, after cancellation, we come to know that this is equal to 9. So 4 11s are 44 and 4 9s are 36 and 4 9s are 36, 11 ones are 11 9s are. So x is 9, so we can easily find out the parallel sides as 3x, which is 3 into 9, 27, and 5x is 5 into 9, which is 45 decimeter. So hence, very easily we can find out the length of the parallel sides. Let us look into this problem. The parallel sides of trapezium are 7 more and 7 less then the distance between them. The distance between the parallel side is height. Find the lengths and the distance between them if the area of trapezium is 169 square meters. Now, parallel sides are 7 more and 7 less than the height. Okay, so we will let K be the height of the trapezium. That is the distance between the parallel sides. So we know that parallel sides is K plus 7 and K minus 7. So if this is the trapezium, height is K. So one side is 7 more than height and one side is 7 less than height. So now we know that area is 169. So we can substitute in the formula. Area of trapezium is equal to half into height into sum of parallel sides. 169 will be equal to half into height is K into K plus 7 plus K minus 7. So we see that plus 7 minus 7 will become 0 and K plus K will become 2K. So half into K into 2K, so 2 gets cancelled. So we know that K square is 169. So K square root of 169 would be K, which is 13. Therefore K is equal to 13 centimeter. That's our height. So let us find the parallel sides. The length of the parallel side 1 will be K plus 7, which is 13 plus 7 and 20 centimeter. And K minus 7 will be 13 minus 7, which is 6 centimeter. And of course, height is 13 centimeter. So hence, the problem is solved. So in our lesson today, we have learned how to solve problem using formulae of trapezium, how to find height, how to find bases. In our next class, we are going to see how to solve problems based on isosceles trapezium. Have a nice day, children. Enjoy learning.